Activestate, and I'm going to give a demo of Staccato, which is our platform as a service that runs on any infrastructure, anywhere. That means it can run on your laptop or Amazon or Rackspace. So I'm Phil Whelan, I'm a developer evangelist for Activestate, but I've actually been working on the Staccato product for the past 18 months, so I know pretty well inside and out. So hopefully you're all aware of what platform as a service is. Private platform as a service is a platform as a service that you can control, so you can run it on your infrastructure, whatever your infrastructure is. Staccato runs on all the hypervisors, and we support many languages. I mean, all languages, and there really is no limitations to that, and all versions of languages. We support a lot out of the box, such as these languages, but if there were certain versions that we didn't support, you could use build packs to install anything you needed. And we support several frameworks out of the box, so it makes it really easy to deploy them. And then on the virtual appliance, which is Staccato, we have lots of resident services such as MySQL, MongoDB, Postgres, Memcached, and a file system, as well as RabbitMQ. We can deploy, as I said, to any cloud, so you can deploy on HP Cloud Services, OpenStack, Amazon Web Services, on your laptop, Savvis, or cloud scaling. So there's different types of clouds: personal, private, public, and hybrid. Most people are familiar with public clouds, like Heroku. And private clouds are ones that you own and you run on your own infrastructure. But you can also have hybrid clouds where you run on your own infrastructure, but you can burst out to a public cloud. So I'm going to give a demo of deploying apps to a few different clouds. I'm going to deploy some on our cluster that's running on Amazon, and also on HP Cloud. So when you download Staccato, it downloads as a virtual machine. It's a virtual appliance. So it will look something like this when you fire it up. It will give you a URL there, and you can go to that URL in your browser, and you'll see Staccato running here. So that's running on your laptop, all of Staccato, and it's ready to push apps to. One thing that I often point people to first is the App Store, because we've taken many open source projects and we've simply added a configuration file in for the most part, just to specify this app needs a database, a file system. We've got many apps on here, and they cover languages: Java, Node, PHP, with backends such as MongoDB, MySQL, RabbitMQ, and Redis. And you can actually go to GitHub. You can click on the more information link here, and you can see these applications on GitHub. So you can actually clone them yourself, tweak them, and then using the command line, just Staccato push your version of your app to either your local instance of Staccato or to your production cloud. So we've tried to cover as many languages and frameworks as possible, so you can easily jump in and start working with those different things. The simplest way to install any of these is simply to click install here. When I click install, I can give it any name I want, so I give it the name ACE. That will actually pull the application down from GitHub, because it's not very good blue on black. But that's actually pulling the application down from GitHub. Might be limited by network capacity here. So that will actually install it, and what happens on Staccato is it fires up a secure Linux container, and it installs everything it needs to inside that Linux container. It provisions any databases or services that it needs. It asks Staccato for those, and they will be injected into the app as credentials and environment variables. So you just use your regular database client or MongoDB client and hook into those provisioned instances of those databases. You can actually reuse provisioned services because you just give them a name. So you can push several apps, all have them talking to the same backend database or communicating over RabbitMQ. So when it installs inside that secure Linux container, when that is finished, it will actually bundle up that Linux container. It's basically like tar-g zipping, and then it will be able to deploy that same instance as many times as you want across your cluster. So you can scale up the application very quickly because all it has to do is drop that Linux container instance and run it. And as your cluster gets larger and larger, you can actually hook into the infrastructure layer and start auto-scaling. So this app is actually running now, and we can go to this URL, and we can see this application running here. And this is actually running on my laptop, on the virtual machine on my laptop, which I downloaded. So within minutes you could download and install any of these applications, such as Jenkins, WordPress, anything you need. And it's exactly the same experience when you do it in the cloud. So Stacker.to is our sandbox. We don't run a public cloud, but we do have a public cloud for demonstration purposes. You can use Staccato on this sandbox for 45 days and use it as much as you want. So we have lots of applications running in here. I think there's around 100 at the moment. So you can see all these applications here. And just as we did on my laptop, we can go to the App Store and deploy an application. Just waiting for the network to catch up. So deploy any of these demo apps. So this one is using a Redis backend. It's a Python application. So when I deploy that, it will install. And this should install a lot quicker because it's not network bound like the one I'm running on my laptop was. So that's installing all the Python dependencies, provisioning a Redis database, and then injecting those credentials from that Redis database into this app. So it's very easy for this application to just hook into those credentials. So that application is now running. I can see it running here on this URL, and if you've got a web browser, you're happy to go visit that URL. I can also make it a lot easier. So instead of currency-7DYBE, I can call it Cloud Expo.stacker.to. And then immediately it's running at Cloud Expo.stacker.to, so you could go to that URL now and see this app running in the cloud. It's running one instance here. So what it can do is I can scale this app up. So I can scale it up to 4 instances, depending on the level of RAM I've allowed as a user. Each user has several different things, such as number of applications, amount of RAM that they are limited by. So if we refresh this page, we can see the 4 instances down here. It takes a little while for the statistics to come in, but all of these instances, or one of those instances, is running. Okay, 2 of those instances are running. I'm not sure why the other 2 haven't started yet. But it will load balance straight away across those multiple instances. Okay, hit my limit. So this particular cluster is running on Amazon. So when you go onto Amazon, if you go through Activestate's webpage, you can put in your Amazon account, and then the Amazon AMI will be able to install. So you just click install that AMI. So this is our cluster here. With all the services, so you've got a Memcache service and MongoDB and the different databases running on this particular node. A DEA is where your application will run inside a secure Linux container. So generally, in a large cluster, it's the DEAs that will grow, because that's where you want to expand your cluster. We have controllers, and they control the whole cluster, all the interaction between the different components, and the interaction with the clients pushing the apps. And we can actually load balance across controllers. So there's a controller here. There's there's 3 controllers in this cluster. They will be load balanced. We have things like the router, and that can also be load balanced. So you can either use the load balancer that comes with Staccato, or you can use, it's best to do it at a hardware level when you do load balancing. So you can also push apps from your you can also push apps from the command line. So I've got the application ACE here. So just going to check I did. Yeah, so it's easy to stop and delete apps. That app is completely disappeared now. So then I can go to the command line and I can push exactly the same app. All I did was check it out from Git. So I did a Git clone, and then clone this app just from the URL, and then Staccato target. So I target my machine, and then Staccato login on philw@activestate.com. So I log in. I already logged in, so it doesn't ask me for my password. So, and then I can simply do Staccato push. If I say no prompts, it would just use everything in the configuration file. So it's a little easier to see white on black than dark blue on black. So you can actually see what's going on here. It's checking the application, it's uploading the application. It will then install all the dependencies. So this is a Node application, so it's using npm to install the Node dependencies, and it's pulling those down off the internet. And graceful pace. And then after this happens, you'll see it provisioning the services. Actually, this application doesn't have any services, so you won't see provision any services. But you can see the staging logs at the end. So it's starting the app, and the app is running on. It says here the app is running on localhost 3000, but that's actually the standard app log from this application. The app thinks it's running on 3000, but it's running in a secure Linux container. When you have Linux containers, you can have many of the same app all thinking they were listening on 3000, but that's actually being redirected and then load balanced through Staccato. So you can look at the Staccato logs. All logs in Staccato are streams. So all the staging logs, the application logs, standard error, standard out, and all system logs are all streamed. So you can stream it straight into Splunk, or for our sandbox cluster we use Paper Trail, and then you can get alerts on different things. Does anyone have any questions? I've got 3 minutes left. Between instances? The question how do we manage load balancing between the instances? That is done by the router. So the router manages sending requests to the right places. So when a request comes in on a particular subdomain, it will send that to the instances, and it will load balance between those instances. And we're working on more configurability around how that's load balanced. And there's also load balancing at the router level. So you've got a router which load balances to instances, but then you can have multiple routers or routers. And we do provide a load balancer, but it's just a software load balancer, so we recommend to our customers that do a more hardware-based load balancer. Any more questions? So, yeah, so we have some basic status graphs on load on the machine, events on the system, which are key events. It's kind of like the log, but plus it can get quite big. We narrow it down to simple events, so it's easy to track. We have groups. So, for instance, you might have a dev team, and you want to be able to all push the same apps and update those apps. So you push as your dev team or your production team or specific projects, and then you can give limits to those groups separate to the users. Okay, and I think that's my time.